right away by firing up Houdini. So here is Houdini 20, but you can do that with Houdini 19.5 and maybe under. Right, so the first thing we want to do is to save our project. So I'm going to save that in my desktop, Icebreaker, and I'm going to call that Icebreaker. Here we go. All right, then the second thing I like to do once I'm inside Houdini is to custom my my UI, customize my UI. So I usually have one that is already made by me for me. And usually it's like I have like a bigger panel for everything that is node based. Here I have my entire parameters that are here. I find it much more useful to have that here. Always a little geometry spreadsheet here. It's always great. And of course, my viewport here. If you don't know how to customize your user interface, you can go there, you know, at the top of every panel and basically say, oh, I want to split it. Let's say here you want to add something else. So you can, you know, let's say, put this here if you want, which I don't. So I'm going to remove this. And once you have your environment set like this, you can, of course, save that. So you can have it easily accessible there. Great. Now our project is saved. It's time to start importing some geometry. So first, let's hit Tab, drop down a geometry node here. Let's call this one a boat. All right. Dive inside, drop a file, and then let's go and grab our boat mesh. So if you look here, this is an OBJ. So we are going to load that. All right, and you can see this is the boat mesh. So this is a kit bash of various boat models that I found online. And basically I redid the UVs and a bit of the modeling. You know, it's not the best model ever, but you know, it does a job for what we need. So let's call that a boat. All right, and then I will drop a file cache load right after, because like as I mentioned, this is an OBJ file format. And this is not the best format to work with in Houdini. You know, Houdini prefers to have BGOs. It will be less heavy to load. So let's do that. So we want to save a single frame, and we want to call that boat as well. So let's see, yeah, boat BGO. Let's call that. All right, boat BGO, and now we can make sure here that the name will be called Icebreaker boat BGO. You can change that if you want, but you know, I will leave it as is. And of course, tick load from disk, save to disk, and now we do have a BGO on disk, which is exactly what we want to move to the next step. So of course, the next step will be to animate this boat, you know, like to have it translate in a way that works for us, and it's easy for us to set up our simulation. So I'm going to drop a transform node, something simple. I'm just going to make sure that the tip of the boat is, let's say, right before the origin, and also make sure that the I don't know how to say in English, but the flotation line, you know, like where the boat has to sit in the water is at the proper place. So let's go into the front view for that. No, sorry, not the front view, left or right, this one, right. Okay, let's see. So I want my water line to be at the origin, so 0 in Y. So yeah, I assume this is correct. So okay, let's move on with that. So let's go back to my perspective view. Yes, perfect. So I have my transform, which is like a move to first frame, let's say. All right. And I'm going to drop another transform, which will be my animation. So I'm going to call that anim. Press C to display your colors here. And I'm going to put it in light blue because I like to, you know, mark or at least color my nodes when they're animated. So anim, I think we can, we could either, you know, like drop a key here, then, oh yeah, of course, my bad. I did something wrong here. Single frame simulation. Why isn't that loading properly? Hold on, I have a little issue here. And of course, I forgot to untick time-dependent cache here. So I need to untick that, go back to save to disk, and now, like it's not an animated cache. So if you look at the previous video that was created, there was a frame padding there, so it shouldn't do that. So yeah, we are correct. So all set. So back to my animation. So as I said, I could very well drop a keyframe here and then move to a random frame and say, let's say, oh, you're translating on Z here, and there you have an animation, which is spline based. So it starts slowly and it ends slowly, but it's not really what we want. So instead, I'd like to delete the channel and put in a little expression, let's say $FF, which basically make the boat move quite fast here, but then we can divide that by however we want. So let's see here, if I activate this little icon here, it will respect the speed of my project, which is set to 24 FPS. So yeah, it's quite fast, but I assume, for example, it would be great for our project, and then we can slow that down if we need. I advise you, if you want to get something very realistic, to check the actual size and the actual speed of an icebreaker boat, but here we don't really care about that. Right, so now we have our animation. Let's drop a null and call that out boat anim. All right, perfect. And now we need to create a collider as well, but that will come later on once we set up our actual grain simulation. So on to the next step. So next step is to set up our grain simulation. So I'm going to drop another geometry node right there. Let's call that grain sim. Okay, and let's dive inside. We are going to create a simple box as a starting point. So box, not backs. All right, perfect. So what's neat about that is that I can place it fairly easily. If I press Shift while moving one of the handles here, it will do that symmetrically, which is quite cool. And for the beginning, while we are setting our simulation, I think it's best to start with something, like simple, just to make sure everything is working, and then we can, add more resolution as we go. If we know that things are working well. So let's have this box. I'm now going to create a dot network, which is where we're going to do our simulation. I'm going to dive inside just to make sure it's selected properly. So basically, I want to make sure that this dot network here is selected here. You can do that manually or just dive in and dive out. You'll see why in a second. And then I'm just simply, I'm just going to use the shelf tool for what we're going to do. So I'm just looking for a vellum right there, and I want to select vellum grain. And you'll see that it will set up everything for us neatly. So here, select your box and then press enter. So of course, it's always great for you to learn how to set up those kind of networks yourself, because you will have to do that in a professional environment. But here, for what we are doing, that's great. Everything's already set up, nothing else to do. So this is exactly what we are after. So now we have our grain here that are stacked. You see here we have our grain option. I'm going to increase the particle size just a little bit for now. And we can have a look at a few different elements. So first of all, if I hit play here, nothing is happening. That's right, we don't have any gravity. So let's add some gravity here, right there. Hitting play, the grain is falling. That's exactly what we want. And now we want to create a ground plane here. So the grain does not fall through infinity, it hits the ground at some point. So let's drop a ground plane. You can plug that directly here. Make sure that just for the sake of this, we just hit play here. Our grain is falling down. Everything is perfect. That's wonderful. We are almost done. That's the beauty of this setup. You can also press Shift R here to invert. I like my network to be, organized from left to right. I find it better, at least for me. And now I want to create a custom shape here. I don't want my eyes to look like a box, so I'd rather have a custom shape. So let's do that, shall we? I'll create a grid, just like a big grid. For me, it will be like a drawing canvas, basically. I'm going to change my display mode as well. And I'm going to draw a curve. So let's see here. Let's use that or not. Let's see. Yeah, it's not the best. Let's change that. So let's go over there and hit draw curve. And now, like it's enabling us to draw whatever we want. So remember, the tip of the boat is right there, just before the origin. So I'm just going to, draw whatever shape I want. And this will be the shape of a little iceberg. All right, so now that it's done, we can put a cap, this thing here. Or maybe you can just say, can you close the curve, stroke? No, let's just use a polycap. Be easier. So now we have the shape that is closed, and now I can say extrude volume. That is going to extrude our shape, but the default behavior is to extrude down. We want to extrude up. So instead of having a depth of -1, let's have a depth of 1. All right. Yeah, the normals are a bit funky, but we don't really care about normals. So 1 meter of ice is a bit ice. So let's say 0.2, and let's drop a normal here. Maybe reverse them. Oh well, doesn't matter. Doesn't really matter. Let's try it now. Well, doesn't matter. So let's plug this newly created iceberg to our grain constraint, and now we should have. Sorry about that. Now we should have. Maybe my grain size is too small. Yeah. We should have some grain that are shaped like our iceberg. That's perfect. So back to our simulation. If I hit play, everything's happening. One thing to note is that if you see on the first frames of the simulation, the grains here, the bottom layer of the grain, is not really sitting on the ground. And that's an issue to me because, it creates this initial fall, which we don't want. So let's make sure that whatever our grain size is, or the grain shape or whatever, let's make sure that this is sitting on the ground floor at any time. So to do that, let's say I want to transform my grains here. So this here sits exactly on the ground. So the idea would be to translate the idea would be to translate this down just a little bit. All right, but every time you will change your grain size, you will have to change this value. So we have to find a rule. So maybe a rule will be to grab the position of the lowest grain in the stack. To do so, let's create an attribute triangle, and let's say that min pos is equal to my position in y. So now here you can see that I have min pos that is equal to my y position. Then I can use an attribute promote to promote that from points to detail. All right, so minimum position here, and the promotion method, I'm going to select give me the minimum. So now if I go to detail here on my geometry spreadsheet, I should be able to see that my minimum position for the grains right now is 0.04. So I'm assuming now that I should move my grain from 0.04, but as you can see, doing so puts our grain our grain center, sorry, right at the origin. We don't want the grain center to be at the origin. We want the bottom of the grain itself, because the grain has a radius. We want the bottom of the grain to sit on the floor. So it would have to be divided by 2, I guess. So what we are going to do is we are going to grab this automatic min pose value first. So to do that, we are going to use an expression called detail, which basically fetch whatever attribute is stored on whatever geometry in your scene, which is like great for me. So let's copy this node. Actually, let's copy this node. So detail, open this symbol here. So that's your attribute promote. Let me make the path relative. So like so, should be okay. Attribute promote, let me check. Yeah, attribute promote. And now we just want to say, okay, what attribute do you want to read? So I'm going to say I want to read min pose. All right, and then I'm just want to have the first component of the value, which only has one component, so it's 0. So I'm going to comma 0, and here we go. So now we have that. So it's moving up 0.04. We wanted to move it down, so I can do that. For the sake of it, I'm going to put some brackets, and I'm going to put minus here. So now it's moving down. That's perfect. But now we want to move it up by the radius of the point. So I'm going to add a plus here. I'm going to go to this here, which is the particle side. I'm going to copy the parameter. I'm going to plus comma plus past relative reference. All right, plus that divided by 2. Not sure if it makes sense, but well, in my mind it does. So just to explain again, you know, the grain is placed arbitrarily into your volume, which is this here. You know, so your grain is not sitting at the bottom. So now you're just saying, okay, I want my grain to be exactly at the 0 axis plus your radius. So now it sits exactly where we want it to sit. All right. But now that we've transformed the geometry here, we need to do the same for the constraints. So I'm going to create a reference copy of this transform node, and I'm going to move it here. And everything should be good to go. So back into our simulation. Now we can see that our bottom layer is not moving at all, which is perfect. This is exactly what we're after. So let me move to origin. Yeah, renaming those, and maybe move to origin, copy. All right. Copy. Make sure our network is clean as well, because as we move on, we want to keep that clean. So let's say grain up. All right, very well. So now that we have our grain simulation that is set up and working and quite fast, as you can see, I want to introduce my boat as a collider. This thing here, I usually, copy that. So that's from, like using the shelf tool from earlier. So I'm just copying that, deleting this, and putting this here. That's great. So that way we can directly import our simulation here. I like to keep pretty much everything into the same object. It's easier for me to navigate, I guess. So here for the boat, now we need to create a collider. So let's select this one here. If you middle click here, you can see that it's not time dependent. So it means that there is no animation applied to it. And if I do the same thing on my animation, you can see that now it's time dependent. So we want to grab the one that's not time dependent, and we want to make a collider from, I would say, the hull piece. So I'm going to select that, hit the Del key on my keyboard while having my mouse onto the viewport. You can see that it's creating a blast node for me. So I'm going to put it here on another network, say I want to delete everything that I did not select. And then I want to see if I can make a collider out of this. So if I were to use a polyfill here, it wouldn't do exactly what I want. It would give me something a bit weird because we have an edge here. So let's see if I can use some trick to select that. Let's try UV connectivity. And you can see that with luck, like most of our boat hull is I don't know how to say, sorry. Most of our boat hull is on a very specific set of UVs, so I can select only the outside faces and not, this ledge here, which I don't want. So once again, having selected what I want, I can press the Del key on my keyboard while hovering my mouse in the viewport. Now reverse that, and yeah, I think we are getting pretty much what I want. Let's try to drop a polyfill right there. Okay, and yeah, that's pretty much filled up. Not exactly. Well, we'll see. If it doesn't work, we'll adjust that. Yeah, okay. So let's drop a null. Let's call that a boat collision. Okay, and now let's put that into our DOP network. So you can see here I still have my DOP network selected from earlier, so I can select this. I can go into the shelf tool collision and say deforming object. All right, select it, press enter, and now we have that. That is perfect. I'm just going to remove the file cache. We shouldn't need it because we don't have any animation here. So, it's just a single frame. Looking at our VDB, everything seems to be pretty much all right for now. Let's fill the interior. Okay, let's keep this VDB size. Okay. All right. So here we have our animation. We don't have any animation, but we have a collider that's set up. Let's go back into our DOP network and see what we've achieved. So going back to the first frame, we now see our boat. And let me change that. Let's go into background. Let's put it to dark. Also, let's hide our ground plane. So to hide it, just simply go here, click that, and you shouldn't see it. Yeah, perfect. Pressing L into your node graph will lay out your nodes, which is perfect. What I can do is put my ground plane here into the static solver branch. It will be perfect. It will be more, much more organized. And now let it play. And now hitting play, you see that, well, first of all, the simulation is a bit slower because now we have a collider. So every time you add the collider, you had some, you're slowing down the simulation. But more importantly, the boat is not moving, which is what we expect because our collider is not made from the animated version of the boat. So now how can we, let's say, import our animation? Well, there are different ways of doing that. The first way is going back to boat. Here we have our animation. I can, action, create a reference copy of that. Okay. And put that here. So now we will have, an animated version of the boat. It will compute a VDB every frame, so that can become a bit heavier. But if I go back to my DOP network, what I can see is now the boat is moving, but you see once again the simulation is slower. The good news, however, is that we have some collision happening and some interaction happening. I can, same way as I hit the ground plane before, I can hide the boat. And it's not updating. Yeah, see. And you can see what's it doing. And that's what we want. But I'm sure there is a more efficient way to import an animation into the network. So rather than having an animated collider, in this example, which is a perfect example for that, we can, instead of having an animated collider, so let's remove that, we can have the animation imported directly into the DOP network. So our VDB, our collision will not be updated. It will not be time dependent, but it will move into the dot network. So let's go into our dot network. Oh, quickly, let me show you this tip for navigation. So if you find yourself going to a lot of different places often, you can set up shortcuts on your keyboard to go there. So what I usually do is my object level, I define that as 1 on my shortcut. So if you press Ctrl+1 here, you can see that I just set a quick mark. If I go into my brain simulation now and I press Ctrl+2, I'm setting another quick mark. And now if I press 1, I'm going back to object, 2, going back into here. And that's great if you often go from place to place. I usually have it set up so my 4 is my out context, my 3 is my material context. We'll see that a bit later on. To me, it's extremely helpful. You can navigate so much faster with that. But back to what I was saying, let's go back into our dot network and let's try to animate our boat. So to do that, there's a node called position here. So is it position or object position? I guess it's position here. And if I translate it, you can see that it's supposed to be translating. Let's say if I say $ff divided by 10, well, it's not moving because maybe set always, that's better. So basically, when you have a node in a dot network that is set to initial, it will only evaluate itself at the first frame of the simulation. And then, consider that, okay, I'm done. This is my first frame. That's all I am. But here we wanted to look at every frame, be like, no, let's look into every frame. Where are you at every frame? Okay, I'm here, and there. So now we can see that our boat is animated and the simulation is faster because, because, it's not reevaluating the collision VDB every frame, it's just like, okay, it's a simple translate for me. So it understands that much better. So nice little tip for you guys that can always improve simulation speed. It's great to know. But here we are not really matching our animation, so let's go back. As you could see, I just used my shortcut here. So let's go back to our animation here. And well, it's the same value I inputted, but let's say you want to change your animation. At some point, it's best to link things. So let's copy this parameter and go back to here, and just say pass relative reference. And now you can make sure that your animation will always match in the dot. So that's great. So back to what I was saying, if we hit play, we can see now that we have some interaction, which is exactly what we want. But you can see, of course, that our grain behavior is not really what we expect from ice. It's looking more like sand right now. So let's change that.